Hello everyone, thank you once again for joining me on this episode. And this episode is dedicated to what is called a AWS Certificate Manager. And we know that it's a very important component of AWS security services landscape. So what exactly is AWS Security Manager, and how does it compare to other services we'll be talking about under the public infrastructure? So let me do this. Let me just compare what we've done. So if AWS KMS and Cloud HSM are the engines that hide raw data and secrets, AWS Certificate Manager is the automated transport manager for the web identity. What does that mean? Now, when there is a communication between a user and a cloud endpoint, that communication, there is a wire, there is a connection between these two endpoints. The guide that ensure that there is security and there is encryption between the user and the cloud endpoint is what we call the certificates, or the TLS, or the SSL. So now what does the certificate do? The certificate has what we call is a certificate. Certificate is a X509, certificate that can encrypt that communication, between the wire that holds the endpoint of user and the cloud endpoint together. That shows that when there's a communication initiated from the user to that endpoint, there is a particular technology that allows that communication to be secured. Now, so how does this compare to cloud, to KMS? So ACM handles the life cycle of the TLS X509 certificate, the digital identity document that establishes secure encrypted HTTPS channel between a user's web browser and the cloud infrastructure. So that is what I just explained. That is what certificate does. Now let's look at the core capabilities. What are those core capabilities within the ACM? So, but mind you, you should remember that Certificate Manager issues and manages certificates. So it's like we have a home through which, or maybe a factory where certificates are produced, are repaired, are managed, and maybe discarded. So let's look at the core capabilities. So number one is zero cost. So for any public certificate provision through ACM and deployed directly into integrated AWS resources like application load balancers, these certificates are free. They are zero cost. So it's completely free. And the benefit, it eliminates the procurement overhead of security budget. It does that. So now the next thing is I want to say is, let's look at DNS versus email validation. Like how do you ensure that certificate authority like AWS, or let me say Amazon Trust Services, can be trusted? You understand me now? So how do you, because at the end of the day, if there is no way of validation, anyone can just set up a certificate authority and use that to fish people. So how do you do that? It's email. They do email verification and they do DNS validation using some best practices. So that is what I want us to just note there. That is a very important point. AWS, and then there's something called AWS Private Certificate Authority. So if you want to set up or stand up an internal public infrastructure as service, instead of you standing up, a certificate authority server within your enterprise, and have to go through all the depth, you can just take advantage of the private CA within AWS ecosystem. It allows you to do almost the same thing of setting up a certificate authority, and you can use that to issue certificate to your internal toolings, internal systems that needs such. Now, what are the business problems that certificate authority solve? So one is that eliminate expired certificate outage. Because this is an automated solution that shows that when you raise a certificate, you request or you sign a certificate, it's the management of that certificate from maybe from that point onward, like renewal and stuff like that, are done automatically by the certificate authority. So this solve the problem of in those days whereby you have a certificate is expired, we have to do it manually and stuff like that. So eliminating expired certificate outage. So the problem, a massive corporate system crashes at midnight because an engineer forgets an Outlook calendar reminder to renew a third-party certificate. This is one of the most common cause of multi-million-dollar tech sector downtime. Yeah, I've worked in an environment whereby my job involved me tracking all the certificates we have within most of our fleet, and make sure that they are renewed as I went due, because you don't know services, some top services are using those certificates to communicate. So if they are expired, then that service will refuse them. So this eliminates that particular kind of outage, potential outage. Eliminate high public infrastructure operational overhead at scale. So now the overhead is like a security or infrastructure engineering team wastes hundreds of hours a year, managing hundreds of domains across spreadsheets, keeping track of keys, creating renewal tickets, managing login to third-party, products to buy certificate, renew and stuff like that. So with this, that overhead is eliminated. So, and then another thing I want to mention is mitigating high CPU handshake overhead. So the problem is that the complex asymmetric mount required to negotiate TLS session connection with thousands of concurrent users takes a massive toll on the server. So computing resources driving up CPU cost and backend services. ACM forces an architectural best practice. Terminate TLS at the edge. You deploy ACM certificate directly into your cloud front or application load balancer. The AWS Edge infrastructure handles the heavy, cryptographic handshake, lifting, passing clean, and onboarding traffic back to your backend. So if you look at this, it's like you give your edge, the job of managing the TLS handshake. That takes that performance, that takes that burden away, that workload away from your internal network. Yes, take it away, and that brings some sort of performance into your environment. So the other thing is preventing shadow credentials and unauthorized issuance. The problem is that sometimes you can have rogue employees or external attackers attempt to spin up unauthorized shadow certificate for your corporate domain using unapproved weak certificate authorities. The solution of best practice outlined in the mandate is using certificate authority authorization DNS record alongside the ACM. By declaring in your DNS that only obt.com is legally allowed to meet certificate for your domain, any other global certificate authority is forced to reject unauthorized. So what this means is that when you specify in your certificate authority authorization DNS record that, okay, this is the only server that can issue certificate, then every other attempt by threat actors to circumvent that system will be rejected as an unauthorized operation. So these are the advantages that you get by managing your your communication encryption between the end user and the cloud endpoint using certificate manager. Using certificate manager, that is ACM. So so this is this. And the one thing I just want to say is that there is, like I said, within the public key infrastructure landscape, we've talked about KMS today. We've talked about cloud HSM. We are talking about ACM right now. And like I said, the HCM, that is hardware security module, is under the hood. This is the hardware that is powering all of them. But when you want to do dedicated tenancy of HSM, that is when you have your cloud HSM. Now, even with that, that shows that your KMS, your secret management, your certificate management, all rely on HSM to do for storage. And the other thing I want to point out is that ACM makes use of certificate or TLS protocol. Use TLS protocol to encrypt communication, network communication over the web, while KMS use keys to encrypt data within your cloud environment. So with this, I come to the end of this episode. See you again.